Thank you, Shrikant. Hey everyone, it's Vinay, and it's really great to see a lot of people on Saturday for the webinar. And I was really excited for this, and your participation will make it more interesting. So, a slight introduction about me. I am founder of AIMLGAN.com. That is a platform where we teach AI and ML for all the AI/ML enthusiasts. Over the past couple of years, we all have seen this AI transformation into our industry in every aspect of, there is hardly any industry where this AI has not made any impact. So the objective of this session was to give something back to the Agile community where I have worked, and I got chance to work with the wonderful people in the Agile section where we did solve many problems. But now this AI has become a problem for the Agilist community. So let's understand what this concept is, and then we will see how we can use this AI thing into our real world life. So before we begin, let me set a couple of expectations that I don't go with the traditional slide way of teaching. I like doing whiteboarding a lot. So at any instant of time, if you have any sort of questions, just please let me know. We will have a Q&A section as well. And this is a kind of learning phase where I am also in the learning stage, and I will try to answer as much as your queries as possible, and together we will learn a lot many things. But before we begin, I would like to understand on a scale of 1 to 5 where you rate yourself in understanding of AI, or to be very specific, LLMs. When we talk about LLMs, on a scale of 1 to 5, you can give numbers. Okay. I hope we all have used various LLM models like ChatGPT and Gemini, right? Perfect. Good. All right. Now, can anybody explain what is a prompt? Any idea? What comes to your mind when you hear this word prompt?
The kind of such sentence what we give to get the info on what we are looking at.
I feel prompt is an information given in return to ask something with the help of a language.
Okay.
The language of communication between us and the Gen AI, whatever tool that we are using, right?
All right. Other thoughts?
So not from the AI perspective, but I mean, would just like to share. I mean, like a prompt would be like when you're like two people are conversing, right? And you prompt them. So that's like giving them a nudge in a particular direction to see what they would then respond, or what they would be sharing, or that basic understanding of what a prompt is.
Okay, very good. So it's okay. It's an input to the LLM in the form of a question. Okay. Prompt is to give a cue to the human being.
Just to make sure that everybody who is not really speaking can go mute. That would be great, actually.
क्या पूछूं? अच्छा.
Okay, thank you so much. So, yes, let's start with this. Right, we all have heard this name, LLM. All right. In short, we call it as LLM, but it's large language model. Right? Primarily, what we have seen over the past few days, or you can say not days or months, we are using LLMs for almost everything. You know, it's always it's always great to conversate with machines in our human languages. Now, earlier days, what used to happen, if you wanted something to come out of the machine, you had to give a technical set of instructions that, hey buddy, invoke this function, right? Take this input and then do the processing and give me the output. That was the interaction that we used to have earlier. But now what happens, we interact with the machine in our natural language, right? The way we conversate. And in your own language, you can conversate with machines now, right? It is not language dependent. You can give input in English, Hindi, Kannada, Tamil, any language. You can interact with these LLMs. So let's understand first, as almost everyone said, almost correctly, that LLM prompt is a mean of, or you can say a way of interacting with these LLMs, right? But let's understand how this LLM works. What exactly is behind the picture of LLM? We all have interacted with GPT or any other model, but what happens when we give this prompt to the LLM? Overall, there are two kinds of segment, which I think from my perspective, that's all my perspective. There may be other perspectives as well. But in the current scenario, I see people who are AI users, right? Who are using AI for their daily task or any other thing or other activities as well. Then the other segment is the people who are building AI, right? Who are creating AI applications, LLMs, and other sort of stuff, right? So today's session is more about this segment, where we will use AI to get the right output. Okay. Now, we all know these are called large language models. Why they are called large language models? Because they primarily interact with us in NLP. We call it as a natural language processing. Now, what happens? There is a bulk of data, right? Which is given to an algorithm, you can say. What it does, it reads this data and it identifies pattern. Okay. It identifies the pattern between the data. We as a human, when we read the sentence or any paragraph or any book, we understand the context, we understand the meaning. But how this machine will understand this grammar, this context, right? The cat sat on the mat. It makes some sense, right? But what if it is cat, mat, sat on the, there is no, like, grammar is not right. So how this machine is learning all these concepts? There is a concept of neural networks. Okay. We are going slightly deeper. We will not do deep dive. Okay, these are other segments. We will discuss them in separate sessions exhaustively. But we all might have heard about these neural networks, right? Deep learning. They are a segment of deep learning. In our mind, we have, like we have brain. We get some input. This brain does some reasoning, and it either gives an output or either it stores or some pattern, right? We read a book, we stored the summary or the visualization of that picture or the book in our mind. So let's say we gave a text or a book to this LLM to read, okay? Now what happens? The first step, what it does, it creates chunks of the data, right? Whenever we get a pizza, we cannot eat a pizza straight away. We create small bite, small sizes of that pizza. And this process is called chunking. So these chunks are created by LLM. Now, once these chunks are created, next step, what happens is your tokenization. Let's understand this tokenization first. For example, we gave a PDF to LLM to read and understand this PDF. It created chunks of paragraph. Let's say Agile principles. Okay, it divided into Agile principles. There are Agile principles. Now, when it comes to tokenization, right? Let's say people over process or interaction over process, right? In tokenization, what happens? The sentence gets divided into words, or you can say groups. These are called tokens. Okay, so these are like the sentence is broken into smaller parts. And then, so now what I am trying to do here is I will explain how this LLM generates its knowledge base, how it reasons. Okay. Now, this tokenization, let's say it gives a specific number. For example, the cat sat on the mat. Let's say this is 0, 1, 2, 3, 4, and 5. It may represent it like this: 0, 1, 2, 3, 4, and 5. This may be a token for this input. Right? Now, the next step, what happens after tokenization is embeddings. Anybody know what an embedding is? Any idea? Have you heard this? Or if you have heard this, what do you know? Or don't know? That's fine. Absolutely fine. No, that's okay. Okay. Now, I will tell.
It is like a pointer to the tokens.
Okay. All right. So now, let's understand. We as a human, when we see this sentence, the cat sat on the mat. Right? For us, it's not a difficult task to understand this sentence. But if we would have written this sentence like this, the cat mat on the sack, then our mind would have said, hey, buddy, this is not right. This is not looking nice, right? Why? Because something is not right here. Why? Because this verb it's more suitable after this cat, right? When we were learning, we were taught grammar like this. Hey, you have to write down now subject and then noun and then object and beautify it with adjective and all of that sort of stuff. Now, let's say this is the noun token. Thank you so much. Yeah. Now, let's say this is a noun. With this noun, the proximity, what should be the proximity? The proximity should be of a verb, right? We call it as a distance, or you can say as a proximity distance. Proximity or a distance parameter. So this model LLM, what it does, it calculates this proximity of every token. Cat with the mat, cat with the sat. The, on, and these are called stop words. It does not care about these words at all. It only extracts the useful token. And then once this token, so for example, if in our sentence we had, for example, the cat sat on the mat, this token, this should be 0. Because the is already there. Again, if the comes, it assigns the same value to that number. So it will write token like this. It will be 0, 1, 2, 3, and then 5. This would be the token. That is the way it extracts the useful information. And then once you have this token ready, it generates this information of token and their proximity distance. Through this proximity distance, through this distance parameter, it understands the grammar or the context of that sentence, right? And when you mix this token and other information, it becomes an embedding. You call this process as an embedding, and the output that you get is a vector. We all must have heard this name, this word vector in our life. Maybe in school days, even if somebody is not from science or any background, even in our 9th and 10th, we study vectors, right? Anybody remember what is a vector?
Speed with direction.
Speed with direction. Okay, that is an example of vector. Okay, now one question. Let me ask this. Can anybody tell
something
where this
direction?
Sorry, this way.
Something with a magnitude and direction.
Correct. Something with magnitude and direction. Absolutely right. Now, can anybody tell where this line is going, which I draw just now?
No.
There is no endpoint for this line.
There is no information, right? We cannot decide like what is the direction. This is a kind of information which is not you can say not complete for us, right? If I'll say, I saw a car moving 40 km/h. Okay, for example, something incident happened, somebody stole a car and police came in and asked me, hey buddy, have you seen the thief? Yeah, I saw him. He went away with 40 km/h. Now tell me which direction. I don't know. How will police go? In which direction? Right? Direction is also important. Right? So these vectors, if you will see in your in our life, these vectors help. They are always there. Like in our surrounding ourselves, we see like somebody gave an example of speed with direction. Speed with direction makes sense, right? But sometimes there are some conditions, like some quantities where we need vectors, where we need direction. Without direction, nothing will work out, right? And there are some situations where we don't need direction. Okay, don't go to a grocery shop and ask, hey buddy, give me 4 kg rice in north direction, right? There it does not make any sense to ask rice of north direction. He might think, hey, might be asking rice coming from North India. These vectors, how they help us? Now, if you'll see this similarity, the cat is more similar, like it makes more sense if sat is near to the cat. So what LLMs does, LLMs create everything in terms of whatever input you give to LLM, whether it is training phase or whether it is an input phase, it converts it into vectors. That vector helps it to find similarity. Now let's say, if we say, like, let's understand there are two people whose way of thinking is like this. Now what can we understand from this, or what can we interpret? This is thinking of person one, think two. Now what can you interpret from this visualization, how their thinking is? Right? Like we can say that, okay, they are thinking in the same direction, right? Their thinking is similar almost, like we can say. Now what about this? If we draw their thinking like this, think one and think two. Now what is the information? Absolutely opposite, I want pizza, somebody says burger. Right? It happens, when you go to a restaurant with your friends, hey, what you will eat? Some people say veg, some people say non-veg. Okay, so this vector, it gave a clear idea about the similarity. It is easy to find, similarities between various vectors. So LLM stores all these vectors which it created in a vector space. We call it as a vector space. Whatever we give to an LLM, it creates this kind of knowledge base. And it stores all those vectors. Whatever information you are giving it to it, it stores all that vectors in that space. And it's really quick to do a lot of, like we see now the chat GPTs and all, they are trained with billions of parameters. They have billions of vectors embedded, like, in their vector space. It is over the past couple of years, now this AI has become a boom. Because why? Because now we have computation power to do all this sort of stuff quickly. And it is going on, it's increasing rapidly day by day. We are getting newer versions of model every, iteration they're coming in. So that is a slight idea about what happens when you train a LLM. So there are two phases. One is your pre-training phase. What you do in pre-training, all this stuff. We just studied the pre-training part. In pre-training part, we give lot of text, lot of data, you can say, to the LLM. It does chunking, then tokenization, then embedding, and then like it stores all that in vector space with all that information that it has learned, right? It stores all that embedding.
Before we go further, I think somebody raised their hand. RP, do you have any question?
Yeah, thank you so much. I was about to ask because same context, Vinay. Thank you so much for the knowledge. So you mentioned about this tokens, embedding, and vector. So are they similar to each other in a sequence, or they're completely different? If you can help us with that.
Sure. They are like okay. Let's understand this tokenization and embedding in vector space. Now, let's say this is a PDF that I wanted my LLM to understand, read this, okay? Read and train. Now, in chunking, what happens? It divides this PDF into small sections. Let's say it extracted one paragraph. That is chunk. I'm saying just random numbers, chunk 1. Now, from this chunk 1, let's say there are 5 sentences. And one of the sentences is AI is a great tool, let's say. It extracted this sentence. Now, when it comes to tokenization, it breaks down the sentences into tokens. Token, you can say as a word, single word. So let's say it assigns some number, 1, 2, 3, 4, 5. Okay, we are just taking numbers, but functioning is this way, but numbering can be anything. It can give any numbers. It represents this sentence like this. This becomes a token. Okay. Now for this token, what is the useful information? Right? AI, great tool. If we write this sentence like this, AI is a tool, great. Now, which one makes more sense? This one or this one? Right? The first one, AI is a great tool. How it understands the context of the input, that what we have given to it. Always remember, I see so many people on LinkedIn, they are cursing LLMs. They are not producing this or that. You never curse children for learning. These LLMs, they are there in the learning phase. They are growing. Let them grow. Let them come to their full potential. And always remember, what you teach to your kid, that kid is going to spit that out itself. LLMs are being trained on the data. If you are giving a good set of data, it will learn that good patterns. And based on that learning, it reasons, it identifies. If we train like this kind of data, it will remember this kind of context. That is why, when you are giving input to the LLM, it is very important to give the right input to get the right output. Now, after this tokenization, it creates embeddings. Now, what this embeddings is? Embeddings is this token with extra information. Now, what is that extra information? That extra information is this. You can say, let's say the distance. There are many things which happen in embedding. I'm just giving one example, but that is kind of relevant example. Like what is the distance of AI with tool? Or let's take this example. Like, what is an distance of AI with great? And then what is with tool? That way, it adds extra information. And that becomes your embeddings. Token plus extra information. And that is represented in form of a vector. Now these vectors, they can be any dimensions. Like they can, if I'll say any dimension, we have one dimension. Like 1, 2, we have 2 dimensions, like in the form of a matrix, 3, 5, 3, 4, 5, 9, and so on. So for LLM, it does not matter whether you have written a poem or a letter. To LLM, it is everything in terms of numbers. It converts everything in terms of numbers. Whatever you give, even if you are giving it an image, it converts that image into vectors. Right? And when these embeddings are done, it stores them in vector space. And that vector space, we generally use vector DB, vector database. We have heard classical databases, right? SQL Server and all that sort of database. But now there is a new generation of database called vector databases, where we store these embeddings. So this is your first phase of pre-training. All this happens when you are training your LLMs. Now you must have, now that once the LLM mod, I hope I have cleared your doubt. Any other doubt is there?
No, thank you so much. So this is more of training the LLM, right? So
correct. This is correct. This is more of a training.
Thank you so much.
And welcome. Now the next phase comes is your fine tuning. Right? We have trained the LLM, but how we are. Okay, I'll explain this. How is it different from metadata? Now, when it comes to, we will come to that on this metadata section, right? Very shortly. We are going to explain this. And that is something which we are discussing now, you can say fine tuning. Okay. Now, in this LLM, in this fine tuning phase, what we do, we test our LLM with prompts. Okay, we give it a prompt, and then LLM practices. LLM practices the output generation. Right? So what happens when you give this prompt? So what exactly is prompt? Everyone said correctly that this prompt is an input. Okay, we will explore more on the prompt as well. So this input, it goes to the LLM, and based on this input, input prompt, whatever it has learned in the training phase, it generates the output. And then you remember when the ChatGPT 3.5 came in, it was like free for everyone. We all trained ChatGPT. There were 2 buttons, like this thumbs up and thumbs down. It asked, hey, did you like the response? If you press thumbs up, it was kind of your reinforcement learning. It learned, hey, this is nice. Okay, I did good. If you turn thumbs down, it rethinks, okay, this is not right. This is not right the way, this is not the right way which I output generated the output. Yeah, Raju, please go ahead.
Yeah, so I hope I'm audible.
Yeah.
Yeah, so my question was that when you are training a model, how much of data would be the right amount of data to kind of, train the model? It is
Okay.
my question. My question is because if you are, explaining, if you are training a kid with, 50 maths problems, and the kid, kind of just memorizes all those 50 maths problems. Now, in the main exam, when an unseen problem comes, then the kid might falter because, he has memorized only the 50, problems that he has been trained with. So my question is that what is the right amount of data that you need to train a model such that when it sees an unseen data, it can come up with some response with a reasonable, accuracy.
Okay. So to answer to that, what is the right amount of data? That depends on your use case primarily, what you are trying to address, right? There are small language model as well, where you are not focusing on all the aspects. You are targeting only specific area. As you see now, there are a lot of jobs for LLM engine like Gen AI engineers who are building. A lot of industries are building their own specific LLMs who are not focused, who are not big like ChatGPT and all. They have a lot of world knowledge, but they are only specific to their only own set of use case. So that the data depends on the use case that you are targeting to solve. First thing. The second thing is when you are training the data, the example that you gave with 15 questions to a kid, when that kid solves that 15 question, what he's trying to understand, it is from our life example as well. When we were given some sort of questions, what we do, we solve those questions, and even our teacher asked, he used to teach us that, hey buddy, understand the thinking that you have applied in solving these problems. The pattern, the logic which you applied in solving those questions. So when the LLM is being trained, it identifies the pattern, it identifies the logic of that input data. And based on that logic, when you give another input, which it has not seen, it tries to apply that logic or that pattern on that set of input that you have given. And based on that, you test your LLM, whether it is right or whether it is not, whether, the logic it has understood. So that is why the more logic you will give it, to the LLM, its learning becomes more and more, you can say the knowledge base increases. So whenever a thing comes in, it applies that sort of logic. So it's like reading as many books as possible, but there is a kind of such thing, you cannot learn everything. So focus on your section. Like if I'm into Agile, then let's read the Agile database, Agile knowledge, and then based on that context, we can answer the questions. Okay. Can we complete the entire flow before moving on to Q&A? Yeah, sure, definitely. Okay. So, all right. So let's. So this was fine tuning phase. So what happened in fine tuning? When you train the LLM, you check the functioning through giving an input prompt. Okay. When this input prompt comes in, you test your LLM. Once you feel that okay, this is important, like this is functioning as per your desired input, then you release that LLM for the mass context. Now, what exactly happens? So here, somebody asked about the metadata. So when we are in the phase of fine tuning, we fine tune our LLM with the help of metadata. And this metadata is also something, let's say, let me explain it like this. This is your front end. And this is your back end. Okay, this back end is your LLM engine, or LLM model, you can say LLM engine, LLM neural network, whatever you want to say. This front end is where, like ChatGPT front end you see, this is where you give your input, right? Now, what happens in between these two, there is a layer which converts your input into a metadata. Okay. This metadata is being fed to your LLM engine. That is understood by your LLM more efficiently, kind of more better way. Okay. Now, as you can see, there are three layers, input, metadata form, and your LLM engine. So now the context or the topic of today's section or today's session with prompt engineering is all about understanding what is, kind of better way, or what is a kind of best way, or what is required by the LLM engine to understand your input more accurately so that it gives output quickly, or not quickly, but in the right way. When LLMs are, when they process any prompt, they are designed, it's like quick answers. They have to give answers quickly. You might have heard recently ChatGPT launched a new model, O1. What it does now, before giving any output, it reasons. It checks what was the input, what is the output that I think, is it okay? It analyzes the input and the output. If it feels like, then it gives the output as compared to the previous models. So the only update is there, it uses some sort of reasoning. Right? So now let's go to this part of prompt engineering. This is a very, I'll say, very important and very big arena. It cannot be understood in just a couple of hours. There are many things which go, but we will try to understand the overall picture, how the things are, and how we can start implementing right from the day one without going into the deep, exhaustive knowledge. Okay, how we can simplify it for our daily life, right? So as we know, prompt is what? Prompt is your input to LLM. Very simple explanation. Or you can say piece of instruction. Somebody said a way of communicating. That is also right. Whatever is the definition that you want to take, but it is something, an input which we tell to LLM to generate a response. It can be any question, any statement, people are using AI for anything now. Now you will see very soon there are people will have virtual friends. What I see in the current, that is my observation, that I'm saying it's not general. But nowadays the only problem is we have a lot of apps in our phone, but we don't have any real friend with whom we can communicate. You must have seen in your corporate world, in your life, the people who think of you as a friend, you think of them as a friend, you share everything, and they share it, they broadcast it with the broader group. the trust factor is going on, but AI is your friend, I'll say. It listens without any bias or something. That is just an off statement. But now, questions and statements. It can be, the type of prompts can be instructional, where we are giving some sort of instructions. Context. This is the most important part of a prompt, the context, right? The LLMs, they are trained on a vast amount of data. Okay. If you will not restrict that, for example, if I ask someone to go and, for example, let's take an example of a grocery shop. Grocery shop, a person is working there. There are different sections in a grocery shop where you find something, placed. Now, if I want rice, where he should look at? He should look at a section where only the rice is stored. He should not start searching for the entire store. Okay, so this context, we call it as a meta prompt. This section we are talking about, this section, middle section. If you will write a generic input, a general prompt, it resembles, or you can say it falls in the first category, the front end. Hey, tell me a poem. That is an input or a simple prompt, a creative prompt, right? Though you might not have trained the LLM on creating on the poems, but it might do something here and there, and it might create a poem. But when we say what is meta prompt, this is the main idea of today's session. We need to understand what is a meta prompt. So meta prompt is primarily a prompt, you can say, which is what it does. It generates, you can say, effective or specific output from AI, right? Let's understand this structure, or you can say the components of meta prompt. What are the components of this meta prompt? So whenever we approach any LLM for any, we have some goal or some task to be performed by the LLM. So first thing is the first component is your task, right? What needs to be done? The next component is your tone, is your style. We will understand also what, right after these components, what happens when we give a prompt to reply. What is the cycle, or what is the backend thing which happens? I will explain that as well. So what is the tone? You can specify how output, or how LLM should produce, how output should sound. Like I'll let sound means what should be the, the style of your output, whether it is formal style, informal, that ways we can express, right? Normally people use ChatGPT for writing emails, right? Write a formal email, write an informal email, that tone you can set. The length. You need to specify the length of the, you need to set the expectation. Set the expectation of the output. Whether you want 100 words, 300 words, or 1,000 words, that you have to specify. If you not specify, it will give you a generic information or a generic, whatever it thinks like. Okay. If you want to be precise, you can specify that, okay, this is the length which I need. And the format. What is the format? For example, you want a bulleted list, a paragraph, or any other sort of format, we can mention. Now, this is the important part, context. Context. Context is providing the, you can say, relevant background. Okay. Now, when we say write a user story, now, okay, it sounds very generic, right? User stories can be written for any kind of project. But what if you are giving it a context? Okay, we are building a login page with, forgot password functionality. Act as the product owner and write the user stories. Then this model gets some context. Okay, we are talking about a web page development. There is this page, and then specific to that, it writes user story. So context, I'll highlight this. This is the most important aspect when you are writing a prompt. And the next part is the constraints. So you need to define what to include or avoid. Okay. Now, before giving one example, I would request everyone to think of these 6 parameters and please write down one prompt from your area, whichever you think like that. It can be any way. If you are into AI, Agile or whatever domain you are working in, using these components, think of one prompt. Okay, whatever task you wanted to do. Maybe you are writing an email, you are summarizing. Just think of one prompt. Okay, and I want everyone who are in this session, I think there are 39 participants apart from 39 or 38. Please, I need at least 25 to 30 prompts who are listening actively now. I'll take 2 minutes of break here. If you want, you can take as well, but I want to drink some water, but I need a prompt. Okay, think of, let's see how we are building our new prompt. And whenever you are interacting with the LLM now, always think of these 6 parameters when you are submitting a prompt. Okay, let's experiment. You can write down your prompts in this chat window.
Vinay, a question here. Mahendra. The session is really going good. Thanks for this. So the question is, so when we give this 6 parameters, it can be embedded in our prompt, or we have to specifically tell this is a task, it should be of this length. Should we use those keywords, or it can be just?
It can be your it can be simple. Let me give one example. Okay, let me give one example.
So if I have to tell this is the context, I can just tell the context. I don't have to tell this is the context. I can just give, I'm going for a picnic.
Correct. You can simply say I'm going on a picnic, for example.
So he'll understand what is the context.
Absolutely. I am going on a picnic with my family or friends. You need to define. You need to set the context. Accordingly, it will advise you the picnic. Otherwise, it will send you to Goa, right? Just kidding. So I'm going on a picnic with my family, or suggest me an itinerary including flights, hotels, and activities for 3 days in bullet format. If you want, you can mention this. It looks good when it gives you a bullet format. Okay, do this. Otherwise, it might give you in the paragraph format that you can also set. Okay. And also that this is not mandatory that you need to specify all these 6 parameters every time. Okay, but for example, length, you can you can mention, but it doesn't make more sense to set a length on the itinerary. It can be detailed, or yeah, you can also mention that length as give me a detailed itinerary. If you want to know each and everything, you have mentioned this detailed, or let me write it in this way. Suggest me a detailed itinerary. You have mentioned length here.
And I want to take a flight with only one stop. That could be the constraint. So you understand that's the constraint.
Absolutely. I don't want 4-star hotels. I don't want direct flight. That can be the context or the constraints. Sorry, not context, but the constraints. What you don't want to include, what you don't want to, avoid. That is something that you can set your prompt now. Now it will, when you give, don't include direct flights. Okay. So when you give a prompt like this, and for example, giving prompt like this, give me itinerary for 3 days vacation. You can compare the response of both the prompts. You can experiment if you have ChatGPT or any other. Okay. All right, we have got some. I hope I have answered your question.
Yeah, thanks.
Can we complete? Okay, ask about strategies for managing changes in Agile project. Write an article about how AI can be helpful to human existence. Be specific and just explain in 10 points and use powerful words. Very good. List down the prerequisites needed to organize a PA planning event in bullet format for my portfolio over the next 6 months. All right. Now, very nice. Now, what do you think of? Let's do some brainstorm on some use cases in Agile. We all have used various tools in our real life, Jira. Jira is now integrated with AI. Provide me a structure to break down roadmap principles for a new product owner. The session will be 1 hour and the content should be easy to understand for someone who is new to the role. Now, here, one concept I would like to discuss. When we are giving any prompt or any input to let's use case we'll discuss a bit later. Let's talk about prompt more. When we are defining the prompt, another apart from the context, this setting, persona, this is also important to for your prompt to set the context. It is, you can say it is a part of the context, but it is very important to set the persona. Let's say act as a, so as there's an example of, act as a product owner, or you can say act as an architect or front-end architect. Then design these documents, act as a scrum master, right? Give these personas, scrum master, product manager, product owner, tester, agile developer, all that sort of personas. When you set the persona, the context of that LLM builds. You can mention scrum master with, you can say 4 years of experience and see the difference. You can mention the collaborative roles as well. That there are many ways of setting up the persona. Okay. Now, once we set the persona, we have our prompt ready. Now tell me, from your experience, do you leave ChatGPT or LLM in the first instance when you give a prompt and you get an output? You ask, hey, write down a user story for this project, and it gives you an output. And you say, hey, this is not useful, or you leave it. No, we don't do that, right? Always remember, prompting is an iterative process. It is an iterative process. You keep on modifying your prompt until you find the best prompt which works for you, right? Correct. Always do an iterative process, and always remember what prompt is working for me, or it's great for me. It might not be great for the others. They can have different expectations, different possibilities. Okay. Now, let's brainstorm this tool that we have used in the last year. Has anybody used the updated Jira? The latest upgrade of Jira, with the AI integration. Okay. If you'll see, like, I have used it not very exhaustively, but the area where I was working as a release manager for McKinsey. And there I was working a lot on Jira. So there I had to create multiple releases and do a lot of activities. And this section, it held my role very easily. Whatever I had to do, like I'll give one example of I had to automate lot many things, lot many Jira automation I had to do. So I used to give so there was one use case where I was like, whenever any release gets created, all the tickets should get automatically created. That is one possibility, where all the release related tickets, for example, there are various activities which happen when you go for a release. So all those release related activities tickets should get automatically created. They should get automatically assigned. And then there was another automation of sequencing these events. When this event happened, then this has to go, and this has to go, this has to go. All those rules were created by NLP. I just gave a prompt that this is something which I want to do, and AI created all this stuff very easily. Confluence, we have used a lot, right? Confluence. Now there is an integration of Confluence and AI with Jira. If you write something in Confluence, and if there is, I have worked on these kind of scenarios. If you write something in Confluence, it will create in Jira. If you write something in Jira, if you have done that sort of integration, for example, whenever we create a sprint, whenever we used to create a sprint, a Confluence page for that sprint automatically gets generated with all the relevant stories and all which are part of that sprint, with that integration and AI. Slack. Now almost all the tools that were being used by Agilists, and still they are being used by Agilists, they are being transformed heavily with AI. All the need is to understand this part, how to do a right prompt. So we will not go into that section, how Scrum Master's life can be made easy, how Product Owner's life can be made easy. They have to make their life easy by themselves by doing iterations on the prompts. The backend. So whenever you say, what happens when Jira and AI works, its backend is still there is some LLM which is interpreting all these stuff, and then it's asking these tools to do some activities. So being an AI user, this is our main section where we need to focus more. Now let's understand what happens when you give this prompt. Okay, how this prompt is being, how this prompt is divided, or how this prompt is broken down, and you get your output. Okay, I'm very sorry if this session is becoming more and more technical. Okay, please do let me know if you are feeling bored, if you're not enjoying. Okay, so we are going to understand transformer architecture. This will be the only section which we will discuss today, and I know it's Saturday, we have a lot of commitments to do. So the hands-on activity part, which I planned that we will do some hands-on, that will be as a kind of self-exploratory activity. All you need is a LLM access. If you have a paid version of LLM, that is wonderful. And if you are still not using paid version, please start doing that. You will feel the difference. I'm not in favor, not in against of any model. You can use any, either you use Gemini, either you use ChatGPT, but start using. Okay, if you want to do a POC, sit with your friend. If you're in your office, if somebody is using the paid version, test your prompts on their machine, see how the output are being generated, and then you can take up a decision of going with your paid version friend. Okay. Now let's understand this.
Vinay, I have one question. Can I ask?
If you can just give me a couple of minutes, let me explain this
Sure,
transformer architecture.
Yeah.
And if you can tell me your context of your question, it is related to what? Then I can see if we can
It's
answer it now.
basically related, Vinay, it's basically related to the output of our prompt, what we get. So we get the data in raw text, right? Let it be ChatGPT or Microsoft Copilot or Google Gemini, right? So any LLM so far, or any basically Gen AI tool so far, which can give a constructive or articulate the content, basically the raw data into a Word document, into a PPT. Do we have any kind of tools?
Yeah,
Or it
that
will be
is
only
what
the raw data.
that is what I'm saying. If you like, I use so primarily, I'll give an example of GPT like 4, right? That is a paid version. If you want, for example, you wanted a code to code in Python, okay, to add two numbers. I'm just giving simple examples. Okay. GPT generates the code. Now, if you want, you can give it a prompt, give me a downloadable IPYNB file. Okay. It is a Jupyter extension file, which runs on Python. It will give you, if you want, give me a Word documentation, give me a downloadable. I have been doing this since a long time back. Give me a downloadable Word documentation file for this code. It will write down all the documentation and it will give you the Word file. Formatting is not great as of now. I will say that's what I said in the beginning. These models, I consider them as a child, they are still in the learning phase. But the speed with which they are learning, it's phenomenal. They are improvising very frequently. Okay.
Sure.
So this GPT can do wonders. And then, as I'm a Microsoft trainer, I'm MCT, so I cherish more on the Microsoft side. So we have something called Copilot. Okay. This Copilot is your LLM integration, you can say, in your various applications. Like Microsoft has embedded this Copilot in almost all of their applications, paid version of their applications. This is your in your PowerPoint, in your Word, everywhere. You will see you don't need to create PowerPoints anymore like normal way. You just give it a prompt that I need a PowerPoint for prompt engineering this session, 7 number of slides, in audience as beginner or expert. Do that ways it will give you a whole list of content and the PPT very easily. Okay, so there are tools, but now what they have done is they have made it a kind of paid version. They are like not giving it for free anymore. All right, now let's understand the last part of this session today is the transformer architecture. And then I hope architecture. And then I hope the LLM, when you understand the functioning of LLM, your prompt gets improved automatically, right? So now we will understand what happens when we give a prompt to reply. Okay. So this transformer architecture is primarily, it uses self-attention mechanism. This is the main you can say, power of LLMs, self-attention mechanism. What we discussed in embeddings, right? That the words like the cat is sitting.
Vinay, we are seeing some other screen. So we are seeing a screen which says explore GPTs that is circled. Is it only for me?
No, I'm sharing my.
Yeah, now it is better.
Yeah, now is the right one is coming.
Okay.
Yeah, the cat
was
is
that?
sitting.
Yeah,
the cat is. Yeah.
Correct.
Continue.
Actually, it will be a request to everyone, don't try to explore different features of Zoom, actually.
Okay. No worries. Okay. So now, what is this self-attention mechanism? What this is? The self-attention mechanism, when we say what it does, when you are giving your input, or when you are in a pre-training phase, or when you are giving your input, what it does, that's what I said, it understands the proximity of words. Okay. The cat is sitting, various proximities. The cat, the is, the sitting, cat is, cat sitting. Now, what next? Now, this has lot of vocabulary already in its system, right? Mountain, floor, kitchen, and so many things. Okay. So in self-attention mechanism, what LLM tries to find, it tries to find the position of words. Okay. They identify, they relate, I would say relate the positions of the words, how the words are being related to each other. Okay. So we have something called short range and long range. Okay. Short range dependencies and long range dependencies, and based on that, it identifies which word should come next. Okay. So whenever you give, we have two concepts called encoder, and one is called decoder. This is the backend of, you can say, this is the working of a GPT model. GPT model works on transformer architecture. Okay. Where you are, so this is a kind of unidirectional encoding. We say it unidirectional encoding, where you have the cat is, or the cat is sitting. So after the, what is the next word? After cat, what is the next word? So this, in this direction, or let's say after cat, what is the next word? It implements self-attention, and then it does the, it finds the relevancy of that word. What is the next word that it should come? We all have seen that, when you write email, please find attached, the next few words already pop in, please find attached my resume, or for your reference. So how that for your reference is coming in? Because of self-attention that it has learned, it is now predicting that you are writing please find attached. You are not going to say please find attached 500 rupees, right? Definitely not. If you will send emails to HR like this, we are going to get hired very soon, right? Okay, please find attach my account password, take out as many as you can, give me a job, right? But there is another concept called BERT. Okay, these are bidirectional encoding representation. Bidirectional encoding representation, where for a word you are checking its relevancy in both the directions. Okay, word after and word before. So when you give a prompt, now that depends on the model that you are choosing, whether you are working on GPT, whether you are working on Gemini. Accordingly, it implements the functionality. Okay, if it is Gemini, it will implement the BERT encoding like principles. If you are on GPT, it will work according to the transformer architecture. But the steps that happen are the same. Your prompt is tokenized, right? It is embedded, or you can say kind of vectorized, I'll say. Then the relationship of the tokens gets finalized, and then it makes the prediction that, okay, this is the input and now what you are trying to. So prediction is kind of generating the output. You have given a prompt, write a poem. Now based on that input, it will start predicting how to write a poem, how poem is written. All that ways it will start predicting, and then it gives you a response. All right. Now, that's the way how LLM works. And I think it will be good to stop at this point. But that is not all. This is only one part, or you can say 5% of the prompt engineering of the concept. But prompt engineering is the main concept for using LLMs in a more efficient way. We will implement prompt. We are not going to code anything at all. It's just you are making your prompt efficient to get the right output. Okay, there are many concepts, there are many things to learn. I think we can do it, reserve it for another sessions or so in the future, but there are many things to learn more. What is zero shot prompting, and there are many other concepts to learn more. And what are there are limitations, right? I read there are memes over the internet. I want AI to wash my dishes and all. Robotics can do that, but there are certain limitations, which LLMs have. So what are those limitations when you are writing your prompt? What you should not do, that we also need to understand. So I think that's all from my side for today's session. And I'll like to have any questions or any feedback, if you questions specifically, and I will try to answer in my best capacity. If I will not be able to answer that now, I will definitely get back with the answers. So over to you, Shrikant. Thank you so much.
Yeah, so I think we can get some questions taken from the people actually, and then I think with that I would like to invite people to ask their questions.
Yeah, and I think recording we will, like Shrikant, you can see if recording is available. But I'll
Yeah,
share.
yeah. So yeah, actually, as far as the session is concerned, we are already recording it, so we'll be sending the recording to all the participants who have joined or even who could not join. And then at the same time, the recording will be available on the YouTube as well. So, so that should be there.
And I will share this like writing pad which I have written. This can also be shared, and my PPT as well. I'm really sorry I don't use PPTs much. I like this way of engagement, so I'll share my PPT as well, which you can refer for your reference.
Vinay, question.
So,
Yeah.
First of all, thanks for the excellent session and getting away from PPT. Vinay, with respect to this persona, where does it stands with the chunks, with the tokenizations, embedding or a vector space? How it is embedded, at what space this is lying? Because that is what is most important to get the correct prompt.
So when you're defining that persona, you are basically setting up the context of that your input prompt, that how it should adjust itself. So that is the kind of your when you are setting a persona, you are setting up the context, you are setting up the expectations, you are setting up the limitations primarily.
Vinay, Shrikant, this is Mahendra. Thanks for the session. It's very nice and simple. I like the style that you explained in a very simple term. So can we have a series of these Shrikant, Vinay? So it's very informative, and I think it's going to be helpful to all of us. So just
sure.
a request. Shrikant, if you can.
Yeah, absolutely. Actually, that is what the intention is, like, to start doing these sessions, and I think this was the first one. So I hope you get the taste of like how sessions look like.
Step by step. Probably if Vinay, I assume this was a foundation, so probably foundation and 1, 2, 3, 4, and we can build up on it.
Correct. So this was the first step, which I thought will be useful for all, and it's not a technical session. It was kind of neutral session. So we will come up with more neutral sessions where people are interested to join those kind of sessions. And if there are certain specific core technology related upgrades, then you can go for the training programs that we provide. So I have a platform called aimlgyan.com where I do all these kind of upskilling sessions for data scientists, artificial engineering, and all that sort of session we can do. But definitely we will come up with sessions which are beneficial for a mass. There will be a kind of series of steps gradually to increase the knowledge.
Thanks, Vinay. Thanks, Shrikant.
Welcome.
Any other specific questions from anybody?
Yeah.
Please.
Yeah. So Vinay, I had a question. It's like assuming if you are using the same prompt for multiple times, does it give you the same result or it varies all time?
It can vary. You can if you're not restricted, it will vary.
Okay. Because actually what was happening is it's like we were doing some POC kind of a thing where basically we were using prompt for creating some cards or some banner kind of a thing. So every time whenever you give the same prompt, but the result
new banner, correct.
you always get a new one.
Correct.
I think there's a.
I think you must be experimenting with the image generation, right? Was it image generation? Yeah. So that image generation model is still, you can say, I'll say that is still in the foundation stages, because I also did a lot of experimentation with the image model, DAL-E. And
the same one.
Correct. So that DAL-E is still like there are still some limitations, where if you, I'll say, first of all, it is not really good with text. If you want some text to be generated in the image,
Yes.
They are distorted. So
Yes.
still there are some controls or fine tunings need to happen on that model as of now.
Yeah, basically the wordings itself goes off. It's like it's not in sync with
Absolutely,
it.
yes, correct, correct.
Thank you.
Yeah.
I
have one question.
Yeah, so I think we can take this as the last question. Thank you.
Okay, so my question is that since the different companies have launched their different chat, GPTs kind of product, right? Like Google has launched, and Microsoft, and the native chat GPT which we all are using. So, first is that, are they using the same or similar kind of uh, backend? I'm sure, like the database, and or they always try to retrain and learn from the live queries. First thing is that, and also like as you said that the more the model is trained, it will give more better answers. So I think out of all these three, I think the chat GPT, because it is a native base product. So I think we can kind of rely on that more rather than on other products, maybe because it has been in the market, and then only the other products were launched, right? For the
So as I say, there are primarily two different architectures. One is like if you use Google, it uses the BERT architecture, and then GPT is based on the transformer architecture. And also the research is in progress for how do we make these LLMs more efficient. Like you might have heard RAG word, right? RAG. It's very hot these days now. So when we say RAG, it's like the companies, what they are trying to do is they are trying to use LLM with their own set of data that the LLM capable, because creating an LLM from the scratch is a very exhaustive task. It requires a lot of I'll say in terms of dollars, or effort, resources. So what these organizations are trying to do is, rather than building from the scratch, they are using these LLMs, integrate it with their own data, implement the advanced RAG techniques to use it in an efficient way. But the LLMs organization like OpenAI and Google, they are upgrading their for example, the ChatGPT o1 which came in recently, they have implemented the reasoning capability. Now with the earlier, the model used to immediately generate response based on the input prompt, but now it reasons. I'll show you. I think I can show this. I have this with me. Just bear with me for a minute. I'll show you this for O1 preview. Okay. And
okay.
All right. I hope it is visible.
Yeah.
Okay. So now I have this model ChatGPT 4o. So there are various models. 4o, right? O1 preview, O1 mini. Now let's talk about O1 preview. It says it uses advanced reasoning, right? Now, let's talk about this. What should we say? What is prompt engineering? Let's see. Okay. Do you think it is useful for getting good results? Just a generic input. Okay. Now it says it's thinking. It's understanding the input prompt. Okay. It's enhancing the clarity. So before giving us this output, it did some series of steps. It says understanding your prompt, right? Now, somebody asked like metadata, right? Meta prompt. Whenever you give a prompt to a model, like this is the front end, it restructures and it creates the meta prompt. So if you will give this effective prompt straight away, your one part of activity is done. You get good results, and then it does all these steps, like it enhances clarity, it refines the instructions, and then it gives the output. So that is the difference between these models now. But if you use the previous model, ChatGPT 4.0, or let's say use the other models like ChatGPT 4 legacy model. Now, if I'll give this input, now let's see. Did you notice the difference? It immediately gave you the response, right? Without doing any kind of inferencing, without doing any kind of logic. Okay. So that is why these organizations are, so these are modifying the way these models are working. But what enterprises are doing, enterprises are using these models now, and they are integrating it with their applications so that their applications are becoming AI enabled. So I'll give one example. There was one organization in US for which I worked on Gen AI. So they had this tool for students, you can say performance evaluation. Now, there was a manual work done by the teacher to assess the grading of the student. What we did, we implemented this Gen AI into the tool, and now all the grading was done by AI. The teacher had to just accept or reject. That's it for all the students. They just have to verify that it is correct. And when they started accepting that, almost when the model achieved a certain degree of accuracy, it was the manual's intervention was also kind of, you can say, removed. It was all AI now. AI is doing everything. They're from assessment to report generation, everything is being done by AI. Yeah.
Okay, I think this is the end of the session, and I hope everyone enjoyed the learning over here. And this is just a beginning, and I think we need to learn more, because the AI world is basically growing from the exponential ways actually these days, and it is important that we are getting updated on this on day-by-day basis. So we'll continue to have these sessions, and apart from this, we'll be having some more sessions as well. So thank you everyone for joining. And thank you for Vinay for sharing your knowledge over here.
Thank you, Shrikant. Thank you everyone for being a wonderful audience. I really enjoyed today's session.
Thank you, everyone.
Thank you. In fact, Vinay, we enjoyed a lot. It was really nice.
Thank you so much.
The way you explained was really amazing. Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.